Well, this lesson is about the concept of the double angle formulas in the HLNSL syllabus. So when you look at the double angle formulas, now why we call them double angle firstly. So if you have got sine theta, uh, cos theta, and tan theta, these are referred as single angles. Like here we got theta, okay? But the moment you get like sine of 2 times theta, cos of 2 times theta, tan of 2 times theta, now these are referred as a double angle. So here what you're doing is you're doubling the angle. Now, if you have sine 3 theta, now for example, sometimes sine cos 4 theta, cos 3 theta, or tan 3 theta, this is triple angle. Now, but as far as the standard level is concerned, you just are expected to remember only the calculations or operations on the double angle. So let's just understand the formulas and the related properties of the double angle concepts. Well, so the double angle, first double angle formula is for the sine. So when you have been given the sine ratio, let's say sine of twice of the angle, so sine of 2 times of the angle is 2 times sine of the first angle times cos of the first angle. So sine 2 theta actually is 2 sines theta cos theta. So basically, if I'm splitting, let's say sine 60, it can be written as 2 sine 30 times cos 30. And you can verify that this comes true. This is root 3 over 2, and this is 2 times half times root 3 over 2. So this answer, actually both the sides are the same. So the double angle formula for sine that you got is 2 sine theta cos theta. If you write down, let's say sine of 4 theta, what you got to just do is actually notice what's happening. Here it is 2 theta, and if you double it, it is double it. What is happening is you're writing 2 times half of this exact angle. So sine 2 theta times cos 2 theta. And for, of course, you can further reduce them, this one to single angle and this one also to single angle. But at least like 4 times an angle, you can write down like this. Now, if you have like sine 8 theta, for example, sine 8 theta, you can factor, or you can just expand this as like 2 sine 4 theta times cos 4 theta. So lots of times the students make this mistake. Okay, they write down this also as 4 or something like that. Please don't do that. So if you have like sine 20 theta, it is 2 sine 10 theta times cos 10 theta. So basically it's none other than just you're rewriting the same angle in different form, same ratio in different form. The double angle for cos is there are 3 double angle formulae. The first one actually is the cos square theta minus sine square theta, 2 cos square theta minus 1, and 1 minus 2 sine square theta. So what we do is, let's say if I have cos 4 theta, I can just rewrite this as 1 minus 2 sine square 2 theta. So whatever is the angle, just like retain these 2's, don't change these 2's. Okay, and this is 2 cos square 2 theta minus 1. And this is cos square 2 theta minus sine square 2 theta. So these are the formulas that are referred for the double angle. Now let's see how do we use these. So here's the simple question that, let's say sine x is 3/4 and your x is known to be in the first quadrant. Find out the exact value of cos x, sine 2x, cos 2x, and tan 2x. So when you got, let's say sine x is 3/4, now you have got, let's say, the identities now, which is sine square theta plus cos square theta is 1. So what you can do is you can just put this value out here. So 3/4 of square plus cos square theta is 1. So cos square theta is 1 minus 9 over 16, which is, this is going to be 7 over 16. So cos theta is plus minus root 7 over 4. Now the same thing you could have done by the triangle method. So it is theta, this is 3, and this is 4, this is root 7. So cos theta is root 7 over 4. Now in this case, you've got to be careful about this quadrant. If this quadrant is second quadrant, then cos will be negative in that, but the rule. So cos x here is the positive root 7 over 4. And you reject negative because in quadrant number 1, cos is positive. Now next comes the sine 2x. Now for sine 2x, what we do is we use the double angle formula. Sine 2x is 2 sine x cos x. So 2 times sine x is 3/4 and cos x was root 7 over 4 that I got from the triangle or the identity. This is x here, this is 3, and this is 4, and this is root 7. So that's how you do the sine 2x. Now for cos 2x, you can use any of this formula, and the first one is pretty interesting because I can directly substitute the value. So 1 minus 2 sine squared theta is for cos 2 theta. And this is nothing but 1 minus 2 times sine theta is 3, 4. So 3, 4 the whole square. And you simplify this, and this is your answer. So lots of times what happens is the students make a mistake. Okay, they just write down sine squared 3, 4. That's like, okay, this is entire thing is sine x value. Okay, so you don't do this. Yeah. Now, as to find out the tan 2x, it is just do sine 2x or cos 2x. So to get the tan 2x. So let's take the exact values that I have calculated down here. So I use the triangle method, then I use the first double angle formula, and here you can see that I use the cosine method, I mean the identity method, to get the exact values. So this is how you use the double angle formulas. And now let's take a look at how we can use the questions, how you can solve the questions using double angle formulas. Now when you're solving questions like solve sine 2x equals to cos x. Now in this case, what's happening is that one of the angle is in double angle form and the other angle is single angle. Now it is mandatory that you convert the angles to both of them to the single angle form for standard level course. So when I write down sine 2x as, let's say, 2 sine x cos x, I don't cancel this. Yeah, if you cancel this out, you lose out the solutions. So you get only two answers using this. But rather than that, you take everything one side, take cos x common, so either cos x is 0 or sin x is half. And cos x is 0 at 90 multiples. So because cos theta comma sin theta is a coordinate, and this coordinate is 0 comma 1, and this is 0 comma minus 1. So cos 90 is 0. So I wanted just 90 degrees because there are no other angles beyond that. Now, second angle is for where cos x is, sin x is half. So sin x is half either here or here, that is 30 degrees and 30 degree here. So 30 degrees is the first angle and second angle is 150. So you got three solutions. And in this case, when you cancel this cos x and cos x, you skip out some solutions. So please do not cancel while you're solving the trig equations. Now let's take another example where you're doing sine 2x equals to cos 2x. So this actually is pretty easy. Sine 2x equals to cos 2x. You just reduce them to tan 2x by dividing both the side by cos 2x. So your range of x is 0 to 180. So range of 2x is 0 to 360. Now you open up the, first you solve for 2x. So you find the range where the tan x is 1. So that is 45 here and 45 here. So the actual answer is 45 and 225, which is this angle and this entire angle, and then divide the answer by 2. So that's how you find out the values. And now let's take one more example for this particular type of concept. So here are some examples that has been like IP has been really interested into. So the cos 2x, if it is equals to cos x, you got to solve for all the possible answers between 0 to 360. So when you solve for this, now one of the angle is the double angle, which I can convert into the single angle. And of course, single angle, you can't do much. So when you solve for it, if you get like a quadratic equation, because cos 2x it is 2 cos square x minus 1. So I replace that here, and then you bring everything one side. You solve for cos x. If you factor out, or you could have taken here cos x as a u or something. It's like 2u square minus u minus 1. If you factor that, it'll be u minus 1 and 2u plus 1. And u is nothing but cos x. So you get cos x is 1 or cos x is negative half. So either the answer is 0, 120, or you know that cos x is, when x is 0, cos x is 1. So this is how you find out the values. So this is the first answer, 120 and 240. But you actually don't take 240 because here, if you see, the range that they have specified is only from 0 to pi. So that's how you basically manipulate and solve this question. Now, here is another example, the second one. You could just go through on your own and you can have a look at the solution in case you don't understand. So I hope this is helpful to find out and understand the basic concept of double angle formulas.